Okay, mayong adlaw sa tanan, mayong adlaw ninyong tulo, Isa, Teo, and Marvy. So this will be this will be the first video nga akong i-upload para sa to ang course. And once again, so sorry about this nga medyo na-delay ang akong pag-upload sa video. But anyway, just have to continue na lang with this setup. Okay. So this is electromagnetism 2. So this is a continuation of the discussion and topics na atong gidiscuss sa previous sem. And sa previous sem, we stopped with special techniques in calculating the electric field. So we are still on that topic. How do I do this? Okay, we are still on this one. So special techniques in calculating the specifically this is electric potential. So in physics, importante kay ni siyang kaning entity. This is electric potential. We've been solving this entity for several weeks already. Okay, kaning electric potential. This is very important nga entity or concept in electromagnetism because murag diha man gud nag-revolve ang electromagnetism. We speak about electric potential, and then later on, this is related to electric potential energy. And then this is also related gid kaayo sa what you call this when you talk about voltage. Okay, so diha man ni siya gikan. This is electric because the unit, by the way, of electric potential is actually volts. Okay, and volts is just joules per unit charge or coulomb. Okay, and mo siya, we have voltage, then you can get into the picture pod ka ng potential difference. So daghan kayo mga important na mga concept na pwede nato mahibaw-an dayon once we know the electric potential. So once we know the electric potential, we can also get later on topic about capacitance because related naman na sila ang capacitance. Actually, inversely related sila sa potential or sa volts. Okay? Then related po siya sa dielectrics. And so on. Okay? That's why we are so focused and we spend so much time on calculating and how to calculate, what to calculate the electric potential of a given system. Okay? In the previous topics, there are so many ways para makalculate ang imuhang potential sa system. And the very basic is katong coulombs, right? Katong mama na siya ang pinaka-general good or basic nga way para makalculate mo ang potential. You can also use Gauss's law. Ang Gauss's law is very specific sa if let's say ang imong system, it contains very high level of symmetry. Let's say a sphere, a cylinder, a plate or sheet, or maybe it could be any, basta naa siya high level of symmetry. You can use Gauss's law to simplify the calculation. But in general, the formula actually for pinakaano gini siya widely used. This is how you calculate the electric potential. You have 1 over R. Then you have the charge distribution, the tau prime. Okay. So this is for volume. For the area, we have sigma. You can replace this with sigma ang rho. Then if this is a line, it's a line charge, the rho will be replaced by a lambda. Okay, so that's how you will are able to calculate the potential. And then once you get the potential, you can actually get the electric field na yun, di ba? As discussed na to last time, you can recall from this formula, you can get a relationship between the potential and then the electric field. Pwede po from the electric field, you can get the potential. Okay? Pero mas medyo difficult na siya nga road. Potential is a scalar quantity. Okay? Scalar quantity na siya. Electric field is a vector quantity. That's why mas sayon jud i-deal ang potential because this is a scalar quantity unlike electric field. Once you get the potential, you can easily get the electric field by virtue of this equation. The gradient is just the gradient or the del of the potential. So getting the potential using this equation is kanisha, it's not all the time useful and sayon siya because not all the time nga what if wala ta kahibaluan na unsa ni siya. Let's say dili given ahead ang charge distribution. Okay ra kung given ang charge distribution so we can easily get the potential. But what if it's not given, right? So medyo lisod ni siya. It's not practical anymore to use this one. That's why a more convenient approach to calculate the potential is by virtue by the use of the equation using the Poissons, right? Equals negative rho over epsilon naught. Okay, so this is a good starting point to calculate for the potential. This is del square. And then if the charge distribution is say 0, walay charge distribution sa surface, then you can say nga ang let's say ang charge is 0, then this equation Poisson's, this is Poisson, will be reduced to just del square V is just okay, this will just be it will be given by this equation, it will be just a Laplace, right? Laplace equation. Okay. So in the previous topic na to, nag-solve tayo, ato ni siyang gigamit kaning Laplace equation, especially this one, Laplace equation. And then we also use the method of images, right? Naka-discuss ta na. You can refer sa previous na video atong method of images. Then for this particular topic, we'll be focusing now on another technique in calculating the potential is, but still use gamit gihapon ta sa Laplace equation and the Poisson equation. We'll be using the method of the separation of variables. Okay, naka-agree naman siguro mo aning separation of variables in your previous topic kasi mathematical physics na apo din sa ubang topic. I think na-discuss siguro niyo sa classical mechanics, maybe sa quantum na asad siya. So, this will not be something new sa inyo ha. Okay? I-apply lang siya sa lahi nga topic. In this case, we'll use the separation of variables sa electromagnetism ng mga problems. Okay? So, consider this problem. Consider this problem, let's say it's example 1. So we have this the color. Okay, this is x-axis, this is z, and then this is y. Kasi na ako'y slab or slot maybe. So, na siya, metal na siya. So, forgive me sa ako ang drawing lang kay I'm not so good at this visualization sa pagdraw. So, imagine ninyo, na siya murag plate dito sa taas, tapos na po siya plate sa ubos. Okay? Tapos, extend na siya to infinity. Okay? Extend na siya dito. This is x, you have the y-axis, and you have the z-axis. Okay, for this problem, let's say ang lower and upper plate kay grounded. So ang potential din is 0. Sa taas po, ang potential niya is 0, grounded siya. But sa kilid, kini siya, at at x equals 0, naa siya potential. Okay? This is at potential niya is b naught, okay, as a function of y. So muna iyang potential. So this is at the origin 0, and then this is y equals, let's say, pi. This is pi na siya nga distance, and then this is 0. Okay? So, balik ta. Okay? So, we have this even. So, grounded ang imuhang plate at y equals 0 and y equals pi. So, kani siya. This is y equals 0, and then this is y equals pi. Kana ang y equals pi. So, ang ihang potential niya is 0. So, both kay 0. However, at x equals 0, so naa siya potential given by this. Yeah. Then we are asked to find what is the potential inside. Okay? So, unsay potential inside sa kaninga system. Dili sa sulod sa duha ka mosyag na sandwich bitaw, sa taas na sa ubos. And kani sa taas 0 ang potential, sa ubos pod 0 ang potential. Okay? Let's try to solve this. Okay? So, we can solve this type of problem. Kani siya. We can use the Poisson equation. We can actually see it here nga ang potential is wala siya dependence sa z. Okay? So, ang potential niya is wala dependent sa z because symmetric man siya. So, ang potential is dependent man siya sa it's not dependent on the path, but dependent siya sa ikan sa taas padulong sa ubos. Okay? So, if calculate mo ang potential sa sulod, ang potential actually is dependent lang sa between x and the y but not on the z. So, di siya dependent sa z. So, this will actually simplify our calculation using Laplace. Okay. So, we have since v is not dependent on z, we have this is solving the Laplace equation in Cartesian coordinates. So we have this equation. So 0. Okay. Take note, ang original equation anak niya is this is from okay, mo na siya. This is 3-dimensional, and then 2-dimensional naman kaya wala may wala no dependence sa z. So this is y square. Okay. And then we establish our boundary condition. So ato ang goal agad actually is to solve for the potential v for as long as ma-satisfy nga equation. Okay? It should be equated to 0. Okay? The second derivative of potential with respect to x squared plus second derivative of the potential with respect to y squared is equated to 0. Okay? So let's go back sa atong problem. The boundary condition Let's look at the bottom plane. So at the bottom plane, unsay atong condition diha. Diba at the bottom plane, balik ta. Ito bottom plane. The bottom plane is at uh, y equals 0. Okay, y equals 0. So nasa yung x, but y niya is 0. So that's the condition. Potential niya is 0 because it is grounded. Then at the top plane, x, that's y equals pi. So pi man na, diba? Tara, pi. So that's equal to 0, grounded. And boundary condition 3 is at take note na sa to ang problem na siya kani siya dinhi na siya plate with a strip. So it's a strip actually nga nag-connect sa duha. Tapos connected na siya with the strip, then maintain at potential V naught Y. Tara. So the plate at x equals 0. So naatay potential di at x equals 0 tapos y. Oh, hindi ko consistent. Sorry. This will be blue. So x equals 0 tapos y. This is v naught, v sub 0 of y. Okay. And then the last boundary condition is, of course, at x, if x at infinity, if ang x extend, you want to find the potential at x at up to, so naa siya din hiba, infinity, what would you expect is the potential is 0. Okay, given this boundary condition, our goal is to find the expression of the potential. So unsa ang potential nga masatisfy ni tanan mga conditions, boundary conditions. Daghang kay sa conditions, no? So upat lang. So sa kanina problem, usa ka ihang potential, okay? So ito dire. So first is mo assume ta og solution. So we'll be using the idea or the concept of the separation of variables. We assume a solution, a general solution sa potential. So we have v as a function of x and y. Okay? So separation of variable, separate ang x, puros x tapos puros y. So we have, di ba, kana? So, kana familiar na sa inyo, ha? So, if this is the solution, ato nang pangitaon sa ng x o sa ng y, so ato nang i-substitute sa ato ang Laplace equation. So substitute. So atong Laplace equation, we have partial v. So ang v na to is x y over x squared plus this one equals 0. So we can safely take out y sa kanang first term. Okay, ang pagderivative na to is with respect to x naman. So we have this plus na. Oops, sorry. This is y squared with respect to y squared. Okay. Next is dapat puros di siya x ang naa sa first term, puros pud y ang naa sa second term. So to do that, we need to multiply the whole equation with or divide by this x and y. Okay? In doing that, mahimo na siyang mahimo na siyang 1 over x plus 1 over y equals 0. Okay? Okay, so we have this. So since ang first term na to is dependent to siya purely sa x, while ang second term is purely dependent to siya sa y. So this can only be satisfied if this one is equated with a constant C1, and then this is constant C2. Okay. Or negative, okay. Negative C1. So we have C1 plus negative C1 equals 0. So satisfy na siya. Okay. So we have this. So let's consider first the first term. Consider the first term first. First term first. Okay. Equals C1. Tapos ang second term, maupod equals negative C1. Okay. So for the C1, ito siyang i-simplify. So you have tapos cross multiply ra nimo siya ang x of C1. Actually, you get this C1 x of x equals 0. Okay, so we can easily solve this one. But first, what if, let's consider if C1 is negative ba or positive. Na kay pwede. So let's try first if C1 is, what if C1 is negative? Pwede ba? Pwede ba nga ang C1 negative siya para ma-satisfy ni siya nga na equation? So let's find out. So if C1 is negative, then C1 is negative, let's say negative k squared. So in this case, negative yun ang C1. Okay. So let's substitute that one. This is plus k squared x of x equals 0. So this is a differential equation and can easily be solved. So I don't need to show the details sa pag-solve ani. You just have to review your differential equation. Basta ang solution na niya would look something like this. Of this form. Okay? Okay? So muna siya ang solution. But let's try to assess if mao ba jud siya nga solution based sa ato ang problem, which is naaman tay mga boundary conditions di ba nga gi-impose. If you notice sa kaning solution, this is dili ni siya applicable because I'm sorry. balik sa da. The solution ani, I'm sorry, nalibog na. Ang solution niya is actually, baliktad, later pa dito. This is A cosine uh, kx plus B cosine kx. Oh, sine. So, cosine and sine, okay? As I've said, so let's evaluate or assess if valid ba ni siya nga solution sa to ang problem. We can say nga dili siya applicable because if you look at the boundary condition number 4, if x approaches infinity, dapat ang potential would be 0. Okay? In this case, if x is infinity, dili siya possible nga ma-zero kani siya nga equation because sinusoidal man ni siya. Right? X ba circular, cyclic man na siya. So, you can go as large as you want sa imong x and y. So, this whole entity will never go to 0. So, di siya mo meet ani nga condition, right? Sa boundary condition number 4. Therefore, this is not the solution. And so, C1 is not negative. Therefore, C1 must be positive. So, C1, so wrong ni siya. So, C1 is not negative. So, it should be positive. So, from this equation, dapat mahimo day siyang dapat positive siya. Okay? Oh, instead of plus k squared, it will be minus k squared x. And ang solution ano niya is kata kong gimension na ganina. Spoiler. So, ang solution niya is a e to the kx plus b e to the negative kx. So, kani siya, okay na ni. Okay. If x approaches infinity, so, kani siya, mo zero na siya. So, okay lang. Okay? Mo zero na siya. So, dapat, if x approaches infinity, dapat, ang x of x mo zero po. So, okay na siya. Okay. The second term is 0. 0 na siya ang second term. So, kani siya, para mo 0 na siya, we can just let the constant a to be 0. Okay? So, we can let this one. So, para ma-satisfy na siya, a should be 0. So, our solution now should be this. So, kana na to ang solution for the x part. Okay? How about for the katong y? Tara. Okay, for the y, we have this is plus C1. So, ang solution ay niya is kani. The solution is of this form. C. So, ang constant na to is constant naman na siya. Naggamit naman tag constant nga A o B. So, kani C and D na po. So, C, ang solution niya is actually sinusoidal. Sinusoidal. KY plus D sin KY. Okay? So, ang solution nato is separation of variable man, di ba? Atong sumpay man ang katong x and y. So we have the solution for the x and the solution for the y. X and y and y. So this is, ang x nato is b e to the negative kx. And then ang ato ang y is this one. C cosine ky plus d sine of ky. So this is our um, solution. And by the way, ang B is constant naman na siya. Pwede na to siya i-distribute sa C and D, ma-absorb siya. So this will be just be this one. Kana lang. E to the negative kx. Then this equation. So that would be our solution. Next is, let's determine what would be the constant C sakay constant D. So we can determine the constant C and D sa ato ang boundary condition. Tara, ang ating mga boundary condition. Okay. So let's consider first the boundary condition 1. So consider the boundary condition number 1. So sa atong boundary condition number 1, that's the bottom plate. At y equals 0, ang iyahang potential is 0. Okay. So let's make use of this kaning equation, right? Na? So we have e to the negative kx c cosine, then since boundary condition number 1 is ang y niya is 0, so this is cosine 0 plus d sine and so this whole potential is 0. Okay, boundary condition number 1, it's grounded katong sa bottom plate. So this is kani 0 na siya automatic, right? Cosine 1 is just cosine 0 is just 1. So we are left with e to the negative kx c equals 0. Now in this case, it's very easy to see nga unsa ang constant c. C is just 0 in this case. Tada. So c is 0. Okay, that's good. Next is we'll use boundary condition number 2. Okay, boundary condition number 2 is katong sa top plate. Tara. At y equals pi, ang potential nimo is 0. Okay. Okay. So at y equals pi, potential is 0. So let's see. Come back with this formula itong gamiton. We have c cosine k pi plus d sine k pi equals 0. Take note nga atong determinant kaganina is ang constant c is 0. So this is 0. So we are left with e to the negative kx d sine k pi equals 0. So para ma-zero ni siya nga entity, kani siya, ito may paggawas. Constant. So either ma-zero na to ang constant na d or kani po ato pwede na siya ma-zero, right? Kani so na siya ma-zero. Kanirang sine k pi or d. It would be meaningless if iset na to ang d equals 0. So wala na tayo i-determine. So di siya useful. What we can do is we can set sine k pi to 0 in this case. So, kanus aman ma-0 ang kaning expression, sine k pi equals 0. That can only be true if ang imong k is integer, right? So could be sine pi is 0, sine 2 pi, 3 pi, 4 pi, and so on. In other words, k should be an integer from 1 up to arbitrary or up to infinity, so to speak. Okay. So how about katong k nga negative, right? Negative k. So allowed ba ang negative na k? So in this case, di siya pwede. Okay, if k is negative, take note sa imong exponential, if mo negative ang k, mo blow up ni siya. So k becomes infinite, negative infinity. So naka-negative diya, so becomes e to the infinite. So dili na so indeterminate na yung equation, infinite times 0. So di siya pwede. Only those positive k ang pwede, ang allowed. Then have boundary condition number 3. Itong boundary condition number 3, at x equals 0, ang potential is v naught of y, di ba? So, again, palit sa katong ato ang formula. So we have at x equals 0, yeah. So we are left with, actually ato ang formula, di ba, is nagsugod man ta ani, then c kay 0. So we are just left with e to the negative kx d. We have sine ky. Since at boundary condition number 3, at x equals 0, this is v naught of y. So at x equals 0, so this becomes e to the 0, so it becomes 1. So this is, we are left with d sine ky. Okay? So and we have also determined the mga values sa k. K katong integer siya, 1, 2, 3, up to infinity. So we can rewrite our equation, our solution now sa to ang Laplace equation sa itong potential. We have d e to the negative kx sine ky. And lahi ang imong value sa imong constant for each k. Kaya ang k nimo is from 1 up to infinity man na siya. So na po d sub k. And then this is, so individual niya, for each k nga value, solution siya sa imong potential. But since daghan kay siya from up to infinity nga k, so lahi nga values, so the most general solution is to take all those solutions, tapos isum nimo siya linear superposition. So isum nimo siya from k equals 1 up to infinity. Okay, that would be the solution now sa to ang kani nga problem. Okay, go back pa din. Yeah, for this problem with this given with this boundary conditions. Okay, so na, so we're not finished yet because wala pa nato na determine ang d sub k nga constant. So unsa kana siya? So to determine, you have to do this. So let's write it again. So to determine dk, we'll use the boundary condition number 3. So at x equals 0, so ang e to the negative kx mawala na siya, so becomes 1. So we are left with dk times sine ky equals p naught of y. Okay, so wala siya. And then to get the dk, ato siyang multiplyan o we'll multiply everything by sine ny. Okay, and then okay, let's ito sang i-multiply. And then we'll integrate the whole thing from 0 to pi. Ito lang integrate. Integrate both sides. So, okay lang siya. Valid ato ang steps. We didn't do anything wrong. What we do sa other side, ato pong ipuhaton sa PCAS side para walay rules na ma-violate. So, given nga ani nga situation, so we can actually calculate for this one. If you notice sa kanya nga integral, that's actually I think na-discuss nyo siya sa mathematical physics and sa uban nga subjects. This is actually an orthonormal set or orthogonal polynomials. So when we have orthogonal polynomials, naara kayo result if ang k nimo is equal to n, otherwise 0 siya, right? So, I think nakaagi na mo ana. So it should be nga ang k should be equal to n, otherwise wala kayo makuha nga result. So in this case, let's equate k equals to n. So k equals to n. Okay? So what will happen is atong i-consider lang na ang kanang integral ha. So if k equals n, so we have 0 to pi sine ky, so we have sine squared, okay, sine squared ky. Okay, but equal man nato, equate na to ang k of n. Then we have, this is dy. Okay, let's integrate this first. So ang integral ani is, if you can look it up sa table of integral, naapa ko diri, table of integral. I can actually look it up na lang. Basta kay ang result niya is ako na lang ihatag din tapos you can check it later. It's actually 1 half y minus 1/4 sine of 2y. Okay, muna ang iyang result sa integral evaluated from 0 to pi. If you do that, we get pi over 2 minus 1/4 sine of 2 pi. 0 naman ano, wala naman tayo minus kay 0, everything is 0 man. Kung evaluate nimo ang 0. So this becomes pi over 2. Okay, going back sa kaning integral. So himo na siyang, so going back, dk, and then the result sa integral is pi over 2. Tapos atong gi-equate nga kn. So na siya delta. Na siya result, pi over 2 siya, otherwise 0 if k is not equal to n. And then the right hand side is just sine ny v naught of y dy. from 0 to pi. Okay. So for this case, dk is just, so we can drop the this summation here. So we can equate dk as this one, 2, 2 over pi okay, so this will be your dk. Muna to ang constant nga dk. So we have actually solved for the potential, which is kani. Solve for the potential sa ato ang system, e to the negative kx sine ky, where dk is just this. Right? Oh, okay. This whole thing is the solution. Kaning dk, that's actually what we call your it's like a Fourier constant. A Fourier series, yeah, if you can recall your Fourier series or Fourier equation. So for this type of problem, kani siya nga system, para this can be solved using Cartesian coordinates. Mo atong gibuhat, that's what we did. And then we establish the boundary conditions for that system. Then given this boundary condition, atong goal is pangitaon ng potential inside sa katunga system. And given this boundary conditions, using Laplace equation, makuha na to ang potential which is unique to the, we can find a unique solution, which is given by this. Medyo taas-taas, no? Pero sa'yo na naman siya, right? Hopefully, ma-follow na siya. So if you have questions, by the way, sa calculation, feel free to comment down below, or you can just directly contact me or DM me, and we can discuss it. Okay. Next is we'll apply this to say what if katulad ang constant sa boundary condition na boundary condition number 3 atong naa sa ang strip niya is maintained at v naught of y. What if constant siya? What if v naught of y is constant? What if v naught? Okay. What will happen to your solution? Okay. This is a special case. So ma-affected ana is kani ang imong dk. We can determine first the dk because it contains the constant v naught y. So that simplifies our equation. So ang dk, we have 2 over pi sine of ky. So v naught is constant, so pwede siya magawas. So kana lang. And then we'll just have to directly integrate this. We have 2 over pi. So this is integral sa sine ky is negative cosine ky. 1 over k. So negative over k. Tapos cosine ky evaluated from 0 to pi. Okay. So you can easily evaluate this result, negative 2 v naught over pi k. That is just cosine k pi minus cosine 0. So this is just negative 2 v naught over pi k Then to ipaon ang negative ato i-distribute atong i-distribute sa sulod. Cosine 0 is not 1. So ato siyang since atong isulod ang negative, this becomes positive 1 minus cosine k pi. Now take a look at this equation. So naatay duha ka sets of solution ani niya, right? So what if k is even? Okay, if k is even, so anything even siya, cosine of something even, cosine 2 pi, cosine 4 pi, and so on. That's actually cosine niya is 1. So 1 minus 1, that's 0. So anything k is even, 2, 4, 6, and so on, it's always 0. Okay, so 0 na siya if k is even. But what if odd? So cosine pi, 3 pi, and so on, that's negative 1 ang result niya. So 1 minus negative 1, that's 1 minus negative 1, that's 2. So the whole thing will just be 4 p naught over pi k if k is odd. So that would be the dk. Now, so the general solution for this will just be itong kanina equation, right? Tara. Muna ang general solution, right? We have solved for the dk. So i-substitute lang nato diha. So that would be a 4 v naught over pi, that's 1 over k, e to the negative kx sine ky. And take note, ang k nato is even man to siya, right? I mean odd. Odd ra siya nga na ay odd ra nga na value if even is 0. So k should be odd. So that would be k runs from 1, 3, and so on. Okay, up to infinity. So this is the solution. The potential of the system if the potential at the slot katong sa x equals 0 sa strip is maintained at a constant potential v naught. Okay, let's have another example. The same gihapon siya nga problem, the same siya nga setup, I mean. So that would mean ana siya. Bati sa drawing. Okay, so ana gihapon siya nga setup. X, this is Z, and this is Y. So the same gihapon ang ato ang given. This is 0, this is pi. Potential sa top plate is 0. Potential sa bottom plate is 0. But sa strip niya at x equals 0, so matunga siya at pi over 2. Okay? So from 0 to pi over 2, so let's say ang potential niya is v naught. Tapos from pi over 2 to pi, it is maintained at negative v naught. So what is the potential inside? So again, we don't have to start from scratch because nag-solve naman taan ni kaganina, and then we can use the general formula that we derived sa previous nga example. So, ang potential sa slot sa katong strip at x equals 0, at x equals 0, 0y, is duha ka case. We have v naught and then negative v naught. V naught siya for if ang y is from 0 up to pi over 2. This is y from pi over 2 to pi. Na. Okay, so we'll solve this. We'll find the potential. So recall the formula. Where dk is just 2 over pi from 0 to pi sine ky v naught of y dy. Okay? Okay, let's consider first finding d sub k. Kinaaman tayo condition, di ba, sa katong potential v naught of y. And then na-divide siya sa duha ka parts from 0 to pi over 2 to pi over 2. So from 0 to pi over 2, so it's positive v naught. So sine ky dy. And then ang ikaduha is other part is from pi over 2 to pi. That's negative v naught. Okay. So we can easily integrate this one since constant naman ang v naught, so we can take that out from the integral. And then the integral of sine ky is negative cosine, negative 1 over k. So that would be 1 over k. So na ako'y k din ha. Then this is cosine ky from 0 to pi over 2 minus, so we have 2v naught over pi k. So this becomes plus kay negative cosine man ang integral sa sine. So we have cosine ky from pi over 2 to pi ang evaluation. Okay? So simplifying this one, atong that would be cosine k pi over 2 minus cosine 0 plus 2v naught over pi k. This would be cosine k pi minus cosine k pi over 2. Right? So this is negative 2v naught over pi k. So this is cosine k pi over 2 minus 1. Okay. So we can simplify this one. atong i-combine ang okay, actually we atong i-combine tanan. So we can notice nga can simplify this as we have 2v naught over pi k. So this whole thing is just c sub k. So sa c sub k, so if k equals 1, so atong evaluate din sa sulod. If k equals 1, this is cosine pi, so this is negative 1, so this is 0. Cosine pi over 2 is 0, so the whole thing is just 0, okay? For C2, cosine 2 pi is 1, 1 plus 1 is 2, minus 2 cosine pi, that would be, cosine pi is negative 1, so this would be positive 2. Oh, balik. Cosine 2 pi is, yeah, cosine 2 pi is 1, so that would be 1 plus 1, that's 2, minus 2 cosine cosine pi, so that's negative, so that's plus, ma-plus na siya. So 2 plus 2 equals 4. So this is 4. So sa C3, if you evaluate that, actually that's 0. For C4 po, that's 0. C5 is 0. Pag C6, mabalik na po siya o 4. Okay? So later on, manotice ninyo nga, actually, ang CK is equivalent to CK plus 4. So ang next na nga na ay value niya, so ang C10 is 4, and so on. So C14 is 4. The rest kay 0. So naa siya pattern, right? So therefore, ang decay, so naa siya, so 4 ang value. So this is 4, so that will be 8 V naught over pi k. 8 V naught over pi k. That is only true if k is 2, if k is 2, 6, 10, and so on. 0 otherwise. So unique po siya og kuan. So therefore, the general solution would look something like this. So ang dk is kani siya nga value. So you have 8 V naught over pi, then 1 over k, e to the negative kx sine ky, right? Where k is 2, 6, 10, and so on to infinity. So this will be the solution for that particular example. Okay? So that will be all for now sa kaning separation of variable for Cartesian. Later on, mag-upload po kong video on, we'll continue our discussion on separation of variables sa spherical coordinates and separation of variables sa cylindrical coordinates. So that's all for now. Goodbye, folks, and stay safe.